We want to finish this lecture by looking at power in particular. So this last section, circuit checksums, is about how to check your work once you finish solving a problem. And although you can sum up voltages and currents and they should all sum to zero if you're doing KVL or KCL, I want to focus here instead on power. So if you solve the circuit properly, when you're all finished, the power absorbed by every element in a circuit must sum to zero. And we're going to show this in the following example. So here we have a circuit with looks like 6 elements, and we're asked to find the power absorbed by every element. And so the approach is going to be to use KVL and KCL to determine all of the element or branch voltages and currents, and then we'll label them on the large schematic as we go. So let's start over here on the left. I'm going to call this VS1 for my first source. We'll have VS2, and wait, I guess I have to put, yeah, so all of our, so we'll just go from left to right here. This is going to be, oops, VS2. This will be VS3 and VS4. And I'm using passive sign convention. The reason I'm using passive sign convention is because once I put a number to the current and the voltage associated with each of these elements, I want to be able to take the product, and I want the wattage that results to be interpreted as the watts that get absorbed by that element. So with that in mind, that's why I chose the convention that I did for VS2, because I want the 2 amp current flowing from left to right to enter the positive terminal. That's also why I'm going to label IS1 as pointing down into the positive terminal of the 12 volt source, and why I label IS3 as pointing down into the positive node of the 7 volt source. Now we need to label the resistor voltage, say VR10, VR1 I guess, and VR2 right here, and I think I have everything labeled now. So next we want to start trying to solve for or identify all of the voltages and currents. So we can begin, let's start with VS1. So I'm going to start over here. VS1 is clearly equal to 12 volts by definition, and IS1 is going to be equal to minus 2 amps, and that is by KCL at this node. We know that 2 amps leave to the right, and so 2 amps must be entering from below, and so that makes IS1 equal to minus 2. From that, we can express the power that is being absorbed by the first source, VS1, and that is PS1 equal to minus 24 watts. So minus 24 watts is absorbed, meaning that 24 watts is supplied. Okay, secondly, let's look at R1. So R1 is right here. Now I know the current going through R1, and again that's by KCL at this node right here. So IR1 is equal to 2 amps by KCL at node B. This is node B right here. And therefore I can calculate the voltage across it. VR1 is going to be equal to 20 volts. And the power dissipated is 40 watts. So that's 40 watts absorbed. Now let's look at IS2. How can I find the voltage across IS2? Well, let's look at this loop right here. If all of the other voltages in that loop have been identified, then I can solve by KVL for VS2. And now that we know VR1, the voltage across the 10 ohm resistor, we can do that. So that's what we do right here. Should be VS2 right there, VS2. Okay, so by KVL, around this loop 1 right here, we're going to have minus VS1 plus VS2 plus VR1 plus VS3. And we substitute values for all of those, and we solve for VS2. We find that VS2 is equal to 15 volts. Okay, now we can calculate the power that is absorbed by PS2, because we now know the current through the source, it's 2 amps, and we know the voltage across it, it's minus 15 amps, so it absorbs minus 30 watts. In other words, it's delivering 30 watts. Next, let's go to the current flowing through, the voltage across the 7 amp source here. Okay, so IS4, I want to say this is IS4, is going to be equal to 7 amps by definition. And then VS4, we can determine that, if you will, by KVL. It's in parallel with the 7 volt source. So VS4 is equal to actually minus 7 volts because of the polarity here. All right, and so now power, PS4, power absorbed by that 7 amp source is going to be 7 amps times 7 volts. Sorry, minus, there should be a minus there. 7 amps times minus 7 volts, leading to minus 49 watts. So minus 49 watts is absorbed. In other words, it's delivering 49 watts. Next, let's look at R2. R2 has a voltage that is going to be equal to the voltage VS3, which is 7 volts. And the current through R2 is just Ohm's law. IR2 is equal to VR2, or 7 volts divided by 1 ohm, and so 7 amps. And the power is V times I, or 49 watts absorbed. Lastly, we have VS3. And there was an order to how I did this. Let's think about VS3. What we need is we need the current IS3 right here. How do we determine that current? Well, we're going to do a KCL right here and around node C. But before we can solve for IS3, we need to know all of the other currents that are entering or leaving that node. Now, we knew the 2 amps from the left. We knew the 7 amps from the right, but we didn't know the current flowing down through the 1 ohm, the IR2. And so we couldn't solve for the current IS3 until we first knew IR2. And so now that we have IR2, we can bring that in over here in our KCL equation. And we solve for IS3 and find it to be 2 amps. 2 amps times 7 volts, 14 watts. And for PS3, there is actually a power that is absorbed. So the other sources are delivering a net amount of power. This one is absorbing a net amount of power. Now, we add all of these powers together. Minus 24 watts, plus 40 watts, minus 30 watts, minus 49 watts, plus 49 watts, and plus 14. And when you add those together, they add up to 0. And so we either have the right answer or we made 2 mistakes or more such that they cancel each other. And I think in this case we have the right answer.